right, here we go. I thought it'd be good to make a video that was a summary of probably 2 or 3 different quizzes that we've had. So we've had some quizzes that I can't remember how many it is at this point, but that deal with concepts like the relative maximum on a curve or the relative minimum. And then these other things called the first and second derivative tests. And I thought it'd be good to see everything in one place with some fairly simple examples. Okay? All right. So say you've got these two curves that are very much alike. Okay, and I just want you to compare them against each other. And I went ahead and drew them just so that we could all agree about what we're dealing with. All right? So this parabola looks like that, and this one looks like that. Here the point is a relative minimum. Right down there, it's 1 for x and 5 for y. Okay, where do I get that? Do I get that from the derivative? No, I get that from the equation of the curve. All right, if I put 1 for x, I mean you do in fact get 5 for y. It's a point on there. Anyway, compare that to this one. All right, so this curve looks this way, and it's got that point at the top that's a relative maximum, which is 1 for x and negative 4 for y. So I created these so that they would have the minimum and the maximum would have the same x coordinate. But look at it like this. Say you're doing your problems back in the quiz that are more complicated than this one. Then you might find that the derivative at a certain spot is 0. Like here on that one, the derivative at 1 is 0. 1 is a critical number on that. And on this one, the derivative at 1 is also 0 because once again, 1's a critical number. But my question is that how does this alone tell these apart? Because what we're thinking is in the lessons, we're trying to learn how to figure out what something looks like without actually seeing it. So suppose that all you knew is this, that I've got this curve and the derivative at 1 is 0. Does that mean it has a minimum or a maximum? How do I tell? All right. Okay, so that's the question I want you to consider. And you see how with these examples, if the derivative was 0 at a certain spot, it could go either way. On this one, it's a minimum, and on this one, it's a maximum. So just consider the question. F prime of 1 is 0 on both curves. How would we know without graphing which curve has a maximum and which curve has a minimum? Okay, so we want to be able to do the math on paper to figure out what's really going on in a picture. And you might say, well, we could just graph it or something like that. But if we draw a graph with a calculator or something like that, it has a limit in its precision, I guess. And then you could, with the equations, you can look at it in as much precision as you want. All right, so I want to learn to see things without actually looking at them. Whether I graph it myself or whether I use a calculator or computer to do it, whatever it is, it's good to know how to do things on paper. So the way that we answered this question here about how we tell those difference is this, either the second derivative test or the first derivative test. Okay, so think of it like this. On this curve, the second derivative is 2. 2 is positive. If the second derivative is positive, that would mean that the curve is concave up. If it's concave up, then it has this shape right here, and the point that we're looking at must be at the bottom because that's what concave up would have to look like. All right. But on this other one, if I find the second derivative, it's negative 2. Well, that would mean it's concave down. And just think about what that shape looks like. What does it look like to be concave down? It looks like this. So that means our point there, the critical number is a maximum. Okay, so that's called the second derivative test. You can find your critical number, and if the second derivative is either positive or negative at that point, then you know the shape of the graph, whether it's concave up or down, and whether the point is a minimum or a maximum. Okay, that's the second derivative test. And I mentioned that one first. I know maybe that seems funny that I did that, but all right, that's what the second derivative test says. That's how we tell them apart. Then the first derivative test goes like this. So that's when we make this chart. Okay, so say for this curve versus this curve, I find the first derivative. I see that it's 0 at 1 in each case, but then I test the sign of the derivative outside of the 1. On this one, I find that it's negative and positive. That tells me the shape of the curve. It tells me that it's falling and then it's rising. Oh, so if it's falling and then it's rising, that means it looks like this. That means that point there at 1 is a minimum, okay? And what about this other one? Okay, so say I find the derivative and I make this chart. At 1, it's 0. Left of that, it's positive. Right of that, it's negative. Well, that means it's rising and then falling. That tells you the shape of that curve. It tells you it looks like this, rising and then falling. Well, so I know the shape of it. Like if it looks like that, that means that point at 1 is a maximum, okay? All right, now every time we give the maximum or minimum point, that is an actual point on the curve, either way. We get it by the original equation for the curve. We don't get the point by the second derivative or the first one. Okay, so hopefully that will be a quick summary, hopefully tying it all together for you, about how you differentiate these, how you tell them apart, what the second derivative test says, and then this one I didn't label it, but I should, what the first derivative test says. Okay, I hope that it helps you to see it all in one place.